One small mistake and you lose. Let's beat the trap with the binomial brilliance. Hello everyone. Today let's solve a question together. This question is from Binomial Theorem, the chapter Binomial Theorem, as you know, and more precisely it is from binomial coefficient, or the properties of binomial coefficient, you can say. Now here is the interesting part of it. While solving this question, we will encounter a trap. But don't worry, we will use our binomial wisdom to escape it smoothly. I will show you two methods. So if you want to give a try, you can give a try prior to watching the solution. The first method I will give you is a bit technical. We will actually solve the question step by step, involving detailed calculation. And all the calculation we will build up on the logic. The second method is based on a sharp observation. You spot the trick, and as soon as you spot the trick, the answer reveals itself almost instantly. So stay with me till the end and let's master the trap together with ease and insight. Let's dive in. So this is the question here, and we have to find out this value. So we can see that what is the numerator and denominator, and we will deal with them separately. So numerator we can write in the expanded form, because starting from 0 to 24 and the 100C4R 100C4R plus 2. So we can write in the expanded form as 100C0 into 100C2 plus 100C4 into 100C6 plus 100C8 into 100C, that is going to be 100C10, and then we can go up to 24, so that will give you 100C96 and two more than that, that is 100C98. So the thing is, many students may think that why not we can transform or just change 100C2 into 100C90, so 100C2 as I can write as 100C98, and 100C6 I can write it as 100C94, and then we can see it's a 100C0 into 100C98, 100C4 into 100C94, 100C8 into 100C90, and so on. And this is giving you like 1 plus x to the power 100 and 1 plus x to the power 100, and we are taking the first coefficient from this and the second coefficient from this. So why not we can say it is equivalent to find out the coefficient of x to the power 98 in the expansion of 1 plus x to the power 200. They actually fell in the trap, and they write the answer as 200C8 for the numerator. Sorry, 200C98 for the numerator. But this is not the fact. And why it is so, let's try to understand this. So why it is not so? Because if I'm looking for 100C98 in the expansion of these two terms or these two binomials, so how the x to the power 98 will be built up? The means we have to also assume the power of x square and x to the power 96. It means for that I need 100C2, and for that I need 100C96. So this you can say it is from here, but no problem. Let me just give another example. Suppose I'm saying why not we can make the 98, the power x to the power 98 from x to the power 3 and x to the power 95. But do you think for this I need 100C3 and for this I need 100C95? I'm going to erase all these things because these are not correct way. That's why I'm writing this way. So this is going to be 3 into 95, and you can see it is not nowhere here. So it is not providing you the fullest coefficient of x to the power 98. Means x to the power 98, if you say in the expansion of 1 plus x to the power 200, will not give you only this much. Some extra terms should be there to say that it is 200C98. So this was a trap the students may fall into, and we have to escape it. So you understand this, it cannot be solved in this way because we cannot say the numerator is 200C98. So then what we do? We have to observe it very carefully. How we can observe it? Let's think in this way. Can I say it is equivalent of finding numerator is the coefficient of x to the power 0 in the expansion of what? In the expansion of, I'm saying this 100 is 0, so I can say it's a 1 plus x to the power 100 by x to the power 0 into 1 plus x to the power 100 by x square. And for this I can write 1 plus x to the power 100 by x to the power 4 and 1 plus x to the power 100 by x to the power 6. In the same way, here I can write 1 plus x to the power 100 by x to the power 8 into 1 plus x to the power 100 by x to the power 10, and so on. I can write 1 plus x to the power 100 x to the power 96 into 1 plus x to the power 100 x to the power 98. So why I'm saying it is a coefficient of x to the power 0, you can see that to find the coefficient of x to the power 0 in this term, what you can think? In this term, how do we find the coefficient of x to the power 0? Because I need coefficient of x to the power 0, so from here I will take 100C0 because denominator I will have x to the power 0, the denominator has nothing. From here I will take the coefficient of x square so that the x square will get cancelled and I will have coefficient of x to the power 0. For this, from this first term, I will take the coefficient of x to the power 4, so I have to write 100C4, and from there I have to take coefficient of x to the power 6 so that I write 100C6. So it is equivalent to find the coefficient of x to the power 0 in this expansion. But if you look at this expansion, you can realize this thing that they are forming a GP, the geometric progression. How? I can take 1 plus x to the power 100 and 1 plus x to the power 100. In each term I multiply them together, so that will give you 1 plus x to the power 200. And then I am left with the first term as x to the power 2, that is x square. The second term will be x to the power 10. The third term will be x to the power 18 in denominator, all of them, and so on. I have 1 by x to the power 194, I believe. Yes. So of course, because I have taken 25 terms, so they all will be the 25 terms, there is no worry. But how do we write the expansion? So expansion I can write as the sum of the geometric series. The first term is 1 by x square, and the common ratio is 1 by x to the power 8, you can see, and number of terms are 25, so you can use the summation of geometric series. Sorry, here I did a mistake, that is 8 only, and so a 1 minus r to the power n divided by 1 minus r. Now let's simplify further. So we can get it 1 plus x to the power 200 as it is, and here I'm writing 1 by x square alone, and I'm dealing with this situation. So that will give you, if you believe it, x to the power 200. If you multiply, I'm also taking the LCM, and 1 and divided by x to the power 200. And this guy in denominator, what is here, we can see this will give you x to the power 8 on the top, and here x to the power 8 minus 1. This we can write. Now what we can do, we can reverse the sign, or here okay. So let me just write in this way. This will give you x squared, that is x to the power 6, and then that will give you, so all simplification will give you 1 by x to the power 194, because I have 202 in the denominator and 8 in the numerator. And here I can reverse the signs of both of them, so I can write 1 minus x to the power 200, and this I can write as 1 minus x to the power 8 to the power minus 1. Now I can write it as this way, 1 plus, not 1 plus, I want to write 1 plus x to the power 200 with this thing. What I'm saying, these two I want to make it together, and these two I want to make it together. So there is a consequence of it. I will show it why, and you will also understand why I'm doing this thing. And this is x to the power 194, and here 1 plus x to the power 200 into, this is 1 minus x to the power 8, you can say, or let me just give you, I got this another trick just in my mind. So I wanted to show you that this is nothing but the infinite sum of a GP whose first term is 1 and the common ratio is x to the power 8. So it's a by 1 minus r. So we can just expand it in that way, and I'm going to write it like this, sorry, and this is what, 1 plus x to the power 200, and this is nothing but 1 plus x to the power 8, x to the power 16, then x to the power 24, and so on. So this is our expansion so far. Now I wanted to write this whole expansion in two parts, because there's a 1 and there's also this thing. So I'm writing this way, 1 plus x to the power 200 into 1 plus x to the power 8, x to the power 16, and you know what is that after, and divided by x to the power 194, and minus this whole thing. What is that? X to the power 200 into 1 plus x, the whole power 200, and then 1 plus x to the power 8, x to the power 16 plus dot dot dot, and divided by x to the power 194. All right, if you just see that 194 in this thing, I can cancel this also, 194 by the way. So that will give you x to the power 6. So I think I can cancel here only, that's okay. So that will give you x to the power 4. Now by any chance, this term will never contribute x to the power 0, because it's already x to the power 4 here. So 4 or 6 is an, oh sorry, this is 6 by the way, not 4, x to the power 194, so 6. And so by any chance this will not contribute 0. So I'm saying that x to the power 0 cannot be found here. And why I'm looking for x to the power 0? Because it actually is the consequence of this first statement in the beginning. We are looking for coefficient of x to the power 0 in this expansion, and we are just carrying this expansion till end until we get the easiest way to think, or easiest expression. So here I don't have x to the power 0, so only x to the power 0 I have here. To find x to the power 0 here, what I need from the top? From the top, I need every term which has the power x to the power 194. then only x to the power 194 will get cancelled and the power of x should be 0. How do we get it? This x to the power 8 is here. So with 1 what we should multiply? We have to think. So we think that to get x to the power 194, I will have what? There's 1 was multiplied there. So you can see that if I take the coefficient of x to the power 194 from here and multiply with 1, I will get. So the first term I can get 200c 194. Then we will also get 200c 186, because when this will multiply to x to the power 8, we will get 194. And then for 16 I need 200c, and how much I need to get 194? 178. And you can notice at the end I can get 200c10 also, and 200c2. So this will be the sequence we get to get x to the power 0 in this coefficient. This is the thing in the numerator we got. Why I made this whole thing? Because you can see that in denominator everything in this is in terms of 200. So I'm taking this thing and cutting it there, and see now what is the denominator we are going to expand and get. So denominator I have is this thing, and if I expand this thing, the first term what we get is 200c2. The second term I get is 200, because starting from 1, so I get 200c 10 and so on. And the last at 24, let us calculate. So at 24, what do I get? 24 times 8 minus 6. So I must get this 186. 200c 186, and at 25 we'll get 200 minus 6, that is 294. So you notice this, everything what we see in this numerator is the same as denominator. Therefore our answer is 1. I hope you understood this whole thing. And this is the method we use, the technical steps. There's one technique we used by making this whole thing in the geometric series by using this fact that the coefficient of x to the power 0 we are writing. The second method is simple observation. So let's take this question again, and how do we solve it? By observation. Now the idea of the second method is just observation. So what is the observation I want to make you? Let's see. Just try to write this denominator in this way. R goes from 1 to 25 I have, but I want to make from 0. So for 0 what I do simply, I again use the dummy variable or this other variable for R. So I want to say that R minus 1 is equal to 0, but that means I can say K is equal to R minus 1. So when R is equal to 1, K was 0. So every R will be replaced by K in this summation as well. So then I get it, summation K goes from 0 to 25. 24, because for K is equal to, for R is equal to 25, this will become 24. And here 200C, and the place of R I am substituting K plus 1. So there will be K plus 1 and minus 6. So this summation will turn into K is equal to 0 and to 24, and I have 200C, and that is going to be 8K plus 2. Alright. Now if this is K goes from 0 to 24 and so on, it doesn't matter actually. We can also use R. There's no problem. So we can write here R goes from 0 to 24 and I can write here 200C 8R plus 2. Now try to observe the numerator once again. This is our denominator, and I want you to understand the numerator, and by simple observation you will get the answer. So the numerator, they are saying R goes from 0 to 24, 100C 4R and 100C 4R plus 2. Now see this beauty that the 4R and 4R plus 2 is just 8R plus 2, isn't it? And why they are equal, let's try to explore it. Why they're equal, let's see. The meaning is that when you're expanding 1 plus x to the power 100, so you are getting there 100C1 x, I mean not 100C0 plus 100C1x plus 100C 2x square, 100C 3x cube, and so on. And let me one more write to it, 100C 4x to the power 4, and so on. The fact is, you are taking, and the second term, I mean second 1 plus x to the power 100, I'm not writing this whole thing. Okay, so I'm writing only this thing. So the first thing will get 100C 2, and then we get 100C 6, and so on. So what is happening when you are multiplying these two, mean the coefficient, how this coefficient will get multiplied. This 100C0 is multiplied to 100C2, correct? And this 100C4 here is multiplied to 100C6. So when you are multiplying in this way, you are actually multiplying the 1 from here and the power x square from there, correct? So we are multiplying here from 1 from here and x square from here. Then you are multiplying to get second, for r is equal to 1, what you are doing, you are multiplying 100C4 and 100C6. It means you are multiplying x to the power 4 and x to the power 6, correct? So when you are multiplying this thing, on the right hand side, what is happening, you have already multiplied 1 plus x to the power 100 or 1 plus x to the power 100. So it will turn into 2x to the power 200. And in this expansion, whatever product you are getting from here, it will go to 1 plus x to the power 200 expansion as 200C8R plus 2. Why? Because you will multiply this 4 from here and this 6 from here, x to the power 6, you are getting x to the power 10. So you are taking 100C4 and 100C6, so it will contribute x to the power 10 in 1 plus x to the power 200. It means 200C8R plus 2 will also give you 200C10 at r is equal to 2 only, and these two are getting the same product at r is equal to 2 only. It means on the numerator, whatever r you are putting, you are actually multiplying the terms of 1 plus x to the power 100 and 1 plus x to the power 100 on the same r. You are also finding the denominator in the expansion of 1 plus x to the power 200. So both r's are same in fact, and that is why you are getting the both terms same. I hope you understood why they are same and why this numerator is not 200C98. So that's all for today. See you in another video. Stay math active.